So John's had this goal for a while now to see if he can finish a Rask by the end of the year. It is December 31st. Will he make it? We've got parts all over the place. Not sure if if he's happy with them, but we'll see what he gets back to us in the front shop by the end of the day. But yeah, really excited to see these Rasks actually in production. So close, hopefully today, but definitely in January.
Hey guys, John Grimsmo here. I have a lot to do today. Let's go. So, the goal is finish a Rask, right? As you can see, I've been playing with a lot of parts. I got more parts over here. Blade, handle, Rask. I was going to send over some handles to the front shop to get tumbled. Sky was going to tumble them for me, but all of these handles, I'm looking through them going, no, I don't like that one, I don't like that one, I don't like that one, I don't like that, I don't like that, that one's not good. I've done changes and tweaks, and I don't actually have any handles that I would call done. So I'm going to get some made on the machine right now, because I think after making all these parts, all the tweaks that I need to make are in Fusion. They just haven't been made yet on the machine. So I think the next one that I make is going to be choice. So let's get that going first. The cool thing with having a CNC machine that runs for hours at a time unattended, and even this one that has the pallet changer that can exchange work, is you can start to schedule things. So get the easy work done first. I'm going to get the back side of the handles, just the inside machine now, because I can get that started in a few minutes and it'll run for an hour. I forget how long it takes. And in that hour, I can finish programming blade bevel grinding is the next trick for me right now. So let's do that. So while I'm posting code to make the backside of the handles, which happens around here on this side, this is my tombstone. It's coming together great. On this side, I get to machine the first side of the bevel, and on this side, the second side of the bevel. So the blade flips over, mounts over here. But as you can see, I've got some issues. This is the ground side, this is the rough end milled side. And while it looks shiny and you can see a reflection, it looks amazing, right? But the surface finish does not tumble out. It's not as smooth as this ground finish, even though the light reflects off it super weird. But the main problem here is that you can see the grinding is missing a whole bunch of sections, and that is not cool. So I machined a Delrin plastic support piece. Once we take the blade off, I'll show you guys. If that is too thick, it's causing the bevel to curl upward, so that when we clamp it down, this section is sticking proud, it's flexing upward. I think that's what's going on, and that's not cool. Also, when it grinds this side, the exact thickness that it grinds to is going to affect, when you flip it, how close or how interference it's hitting that Delrin insert, and that could be bad. So I've been tracking the data for the thickness of that, and it tells me a few things. But for now, let's make these handles on the back. Okay, so here I've got tombstone handle back sides. I'm not going to go too deep into this, just want to show you guys real quick. These are all my operations. I've got one chunk there, and then I press in the detent ball, grind the detent ball, and then I've got another chunk of operations here. Quite a lot of operations. I think there's 50 operations just to the inside of the handles. Fusion 360 has a sweet update that came out a couple months ago, I forget, that this is new. There's a little toggle button down here, stock visibility, display in process stock or transparent stock. I've got them both turned on so that every operation, it's like a simulation built in. It shows me this is the operation I just did. And then next one would be lightweight pockets, and then do these little cutouts. Quick fact, the reason I'm doing this little cutout is because this thick lip, when you flip it over and cut it off, was becoming a ring all the way around that would kind of fly off and cause a ding in the side of the part. So if I slice it, then now I've got two chunks that fly off, and it works great. But yeah, the in-process stock is amazing, because then you can see, it's not the most accurate because it's a quick and dirty rendering, but I can see that my chamfer goes slightly bigger than my hole here, which is awesome because I spot it and then I drill it and I'm left with a little bit of a chamfer for the detent ball. Perfect. And then you can go all the way to the end and you can be like, it's got to think. Where'd all my stock go? There it is. You can see the starburst pattern and everything. Cool, so I'm gonna post this right now. I'm gonna run it through Camplete. And then Camplete does its magic. Okay, so I have posted my updated handle backside code, ran it through Camplete, everything checks out good. I've used TNC Remo to wirelessly send the file the 4 feet from that computer to this computer, but now it's here. And then I just gotta make sure I'm opening up the right file. I gotta tweak something real quick, and then I'm gonna run that. Perfect opportunity to run a little time lapse on this, this rig that I haven't tried yet.
Should be good.
Yeah. It's going really good. Okay, so it's doing the engraving right now at 40,000 RPM. This thing goes up to 42. I don't know why I chose 40 over 42, but it's fast. So I'm engraving some very fine words on the inside of the handles. The date, I hope it says, I think this one says December. And then, I think that's it. Yeah. Okay, so now at this point, it tells me, there's a pause in the code, it tells me open the door and put the detent ball in because it's an in-process operation. So I've drilled the hole, I've chamfered it, I've done a bunch of other milling as well, and now I open the door, blow it off, place a ceramic detent ball inside, and the machine probes it, measures it, presses it in, probes it again, so I have a statistical value of what the height actually is, because the height of a detent ball in the handle is insanely critical for consistency. And then it grinds it, and then it continues with all the other machining. So that's what I'm doing right now. Let's take a peek here. Okay, a couple things I noticed right away. It is burring up. If it'll focus, you'll be able to tell. I can see burrs are forming from this roughing tool, which tells me the tool is getting older and getting dull. Now, later operation is going to come in and chamfer that away, but it's nice to be able to see it mid-process so that I know the age of that tool and the condition of that tool so that I don't let it get away from me. Because if it chamfers it away, you never see it, you never know. So not a big deal. I use this tool for a lot of things. It's like my default roughing tool. So eventually I'm going to have a dedicated tool just for that, so it should last a lot longer. Got my date engraving right there. It does say December, which is good. And then I did another nice little hack over here. So you can see there's several different spotted or drilled holes. And these two holes are the same diameter drill, but they're for different purposes. One is for the detent ball and one is just clearance. So I drew a circle around, I engraved a circle around where the detent ball goes so that the installer, me for now, but other guys later, know where to put the detent ball and not in the wrong hole. And then that circle gets milled away in a further operation, like it's just, there's nothing there. So that worked out really good. Nice little trick that I put in there. Okay, let's go grab a detent ball. They are over here at the Mori because I don't have my own little stash yet, which takes 0 time to do. But for now, I do it the slow, dumb way, and I come over here and I grab one, and then I bring it back. Okay, got it. It's in there. So dropping the detent ball by hand like that it's fine for now. I have other things to worry about, so I'm going to keep doing it that way for the next little bit. But I've been thinking for years about doing it automatically, having the machine automatically have a little hopper of balls in a tool holder. Tool changer brings it in, it's got a hopper, and it presses, it drops the ball, one ball at a time. As it touches the surface, one ball comes out, changes away. It's good for next time. That is completely possible. It's some very tight, intricate machining, and I have most of it designed. I've been on other projects lately, so that has not been a priority. But once production is happening, that will become the priority, and I'll get it done. But for now, I have no problem doing it manually. Okay, I put the ball in, I'll close the door, hit go. Brings in the Bloom spindle probe. The rapids on the probe are default set to be slower, just as standard. It comes down, it touches the top of the ball, and then it touches the top of the handle and establishes a starting thickness, a difference between the two. And then this is literally a drill bit upside down with a dimple milled in the bottom of it. Spinning at super slow. It presses it in once, weird stupid retraction at the end there. Tool change back to the probe, measure, compare, and then we have our pressed height. And it is super consistent and super repeatable and super awesome. So now, some here in the Q parameters, there is math that tells me all the information I need to know. And then we go on to machining. Check this out. Campleat's simulating this file right now. It shows it pretty clearly. As I'm doing the starburst pattern on these handles, I decided to tilt the table 45 degrees so that the tool, let me slow it down so it looks a bit more natural here. I decided to tilt the table 45 degrees so that we're cutting with the side of the ball mill. Very important to get a really nice finish. When you cut with the center of a ball mill, let me grab one real quick. When you cut, hopefully our lighting is decent here. We got a ball mill here, right? When you cut with the very center, like if you're surfacing something like this, for one thing, the flutes in the center are not like super sharp. They come to a point, but grinding tools have a limit. And there's only so much they can do at the very, very, very center. The further away from the center you get, the more scooping action you can achieve. So you think about cutting with the sides of the tool, you're scooping material away. When you're cutting with the dead center, you're kind of just rubbing. And usually you can get away with it. But when you can tilt the tool, and you got your Rasks handle here, imagine if you're cutting all that pattern with just the tippy tip. It's not ideal. If you can tilt the tool and go like this, now you're scooping every time. And you just get a better cut quality. And not only that, but it also changes your surface foot per minute, which is directly relational to the diameter of your tool. At the very tippy, it's like you have to spin the tool at a bajillion RPM to get a decent SFM. And you go a little bit out, you bit more. But if you tell the tool, this happens to be a 3/8 tool, if you tell Fusion that I've got a 3/8 tool, but you're actually only using an effective cutting diameter of like 20 thou, then your RPM is going to be screwed. It's going to be all messed up. So try to keep that in mind while you're using a ball mill, and if you can, tip it. You don't need a 5-axis to be able to tip it. You can make a fixture on a 3-axis machine and tip at whatever angle you want and then be able to machine it. So things to think about. On the first batch of Rasks, which this one happens to be from the first batch, we just went straight on and it was fine. It worked fine. Here's a DLC coded one. It's fine. But Come on. There. I mean, I'm looking at this in the camera now. It is fine. It looks great. On this crosshatch pattern, it looks great. You get into the starburst, like on this one, and with these bigger flutes in the back, and the real problem starts to happen because there's this thing in machining called climb milling. When you're going on the outside, you go clockwise. If you machine the outside counterclockwise, you will get a garbage finish. So you want to climb mill with carbide, so clockwise for the outside, counterclockwise for the inside. When you're dragging it through a slot like this, just like one of these, one wall will be climb milling and the other wall will be conventional milling. So if you look under the microscope and you just go like this, especially as you get more bigger grooves, bigger definitions, if I'm going this direction, the right side of that gully is going to be nice, the left side is going to be smeary. But if I can tilt it, now I'm climb milling on both sides of the gully and it looks fantastic. So yeah, I've got one here. This is directly off the machine. No tumbling, no finishing, no focus apparently. And it's good. It's really good. It's clean. This particular one is one of the reasons I'm not happy with it. It's because I have this crosshair line down the middle and a little bit in the front, I think. I was testing some different theories and it did not work. So I'm not happy with this one. But otherwise, it's fine. Just that little aesthetic detail. Handles are done. Open the door. Take a little peek. Yep, they look good. I mean, sometimes it's not until you get closer do you realize if things are actually really, really good or not. You start looking under the microscope or measuring things or checking threads or features or burrs or whatever, but through the camera it looks pretty good so far. So, cool thing I want to talk about is the X shape. Okay, so old Rasks were made like this. This is the lightweight milling pockets on the inside. Come on, Canon M50. There you go. Pretty cool, pretty cool. But we were wondering, as I was assembling some of the knives, I was wondering if I was having some warping issues. You assemble the knife, and I've done so many of our knives now that I can tell if it feels kind of weird, if it's not dropping properly, or if it's not like, if something's wrong with it. And as I was assembling the first few knives, I was wondering if the handles were buckling, if they were curling just ever so slightly, because they're machined literally on all sides. There's no flat surfaces left. This is a radiused contour on the top. Even the backside face is now like end milled flat, and we were seeing, I think on some of them we were seeing some where the ball bearings roll in here, it would roll in heavier on one side or the other, which kind of led me to wonder if they were curling. And you look at the design of this with basically a bend point right in the middle, and especially on this one, you see it like, it kind of makes logical sense that it might just want to naturally curl with the support point right there. So it was Angelo's idea to do the, I'm calling it the X-wing shape, but whatever you want to call it. And I think they turned out pretty good. We took some die chem on this one and we're playing around with flattening and sanding and stuff like that. But I think the X shape, it looks better. I think it's going to provide more rigidity. The problem kind of went away, or maybe it was never a problem to begin with, but I think it looks amazing. And then the other thing we're doing is we're trying to match, we have starburst pattern on the outside, I'm matching starburst pattern on the inside. It's a radial tool path that goes from the pivot and fans outward at a 1 degree or 3 degree, whatever I chose, linear line, but only in the areas that I select, the places that I want it to be. So when I go to other patterns on the outside, like crosshatch or whatever, I'm going to try to match that on the inside, which does provide some logistical nightmares because now you have two separate operations, backside by itself, and then you flip it to the front side and both have to match. And if you're switching between patterns, it might get a little confusing. So we'll see, but it looks continuous and it looks amazing to have them match. I think it's pretty cool. So I had my kids in here the other day and I was showing Leif how to tighten these down, and I realized I gave him the drill to do it and he just starts cranking on it. I'm like, hold on, you can't just crank on it because you're likely to cross thread some of the screws depending on the situation and stuff. Like this thread starts at the very top. So I always like to at least start it like one turn by hand and I'm happy. Or if you're, you know, super careful, you can go in and gently with the drill. Okay, I know that's going in. You can't just He-Man this stuff. So usually we'll tighten this down with the impact and then not super tight, or just to flat, and then we've got this amazing Sandvik torque wrench that we've got it set to the proper Newton meters for this metric M6 thread. Tight. Beauty. Handle top sides are getting machined. Interesting. Can you hear that squeal? See if I can get this on shot. Having a bit of an issue with the starburst pattern. Notice how the pilot is tilted like I was talking about. See those dots and that squeal? I just heard it again. Once this clears up, we'll be able to see those dots on the fixture right there. I should really stop this, but I'm showing you guys. There's that squeal again. The new toolpath for the starburst, whatever I changed, is now digging down deep into the fixture and dimpling it. There's that squeal again. This is not good for the tool, but I'm showing you guys an example. Yeah, it's digging into the fixture. That one didn't do it. Yeah, I'll have to look at the fusion, see what's going on, make sure it doesn't get worse. These lines right there. Luckily, where'd it go? Luckily, it's only a few lines, only the few that happen. If I hide everything else, we should be able to look and see. Okay, so there's like 1, 2, 3, 4, 5, 6, 7 lines. Yeah, we went through all those. All these should not matter, and they're all at the same plane. Let's go to the second side here. Yeah, we're good, we're good. I knew about this one. I knew that was going to be I remember seeing this when I changed it all a few weeks ago. And that might dig again, but whatever. I'll let it self-clearance once, and then we'll see. Oh, wait. Interesting. You can see right here it's digging into the handle too, but this might be, sorry, I'm out of frame. You can see here where it's digging into the handle, but that is probably where the lock bar insert cutout is. So it's here. So it might actually not leave a dent. We'll see. So I absolutely love how we have windows, 4 windows, 2 on this side, 2 on that side in this shop. Except, if I'm getting picky, there are a couple times in the day throughout the year where the sun just blasts me right at my table here. And then like, whenever somebody's standing there talking to me and they move their head like into the light, out of the light, and I'm staring at them like this, It's it's like, can you please move over just a little bit so I can see you? But so we'll probably get some blinds at some point, probably just for that window. I don't know, something just to cover it, just to cut it, a white bed sheet or something. I don't know. It needs some. I mean, I've been living with it for a year, and at different times of the year, it's a problem or it's not a problem, depending on the sun. So, okay. Handles are going good. All right, handle top sides are machined. In there. Meanwhile, I got the Delrin blade support insert tweaks done. So we'll pull the handles off, check them out, get them to the tumbler. I'm at the point, it's 3:23 right now. I know some of the guys are leaving earlier. Eric will probably be here a bit later with me. It is New Year's Eve, so I don't want to stay too late. And then we're taking a couple days off. I'm just trying to logisticize in my head, what level am I calling done Rask? You know, it has to go in the tumbler for 2 hours. It's a lot of time commitment for now. I still have to make the blade, the bevels, so yeah, okay, I'll get to the handles and the tumbler right now. Let's do that. You can see the dimples right here, but it didn't affect the handle whatsoever. The handle is beautiful and good to go, so that's good. So I mean, it's no big deal. It's not good on the end mill, obviously, to do a bunch of dips like that, but if this toolpath works, if I'm happy with it, then I'll leave it, and then those holes are there forever, and it's fine, and I don't have to worry about it. The ones we were looking at over here did not hit the fixture or the handle, so we are golden. Golden! They look good from here. Once I clean them up, we'll see how good they really look. Jiminy Cricket. It did dimple the handles. There are 4 little dimples on that upper handle. Or maybe a couple more, actually. 5 or 6. Ah, crikey. I don't love that. That's on the display handle. I might have a good display handle. Now, I don't think it's the toolpath itself that did that. It was the extra cutting forces from when the tool hit the fixture and like vibrated a little bit. I bet you that's what did it. I bet you if I made another one, they wouldn't do that. But I don't know if I want to spend the next hour making another one. I want to get to blades. All right, heading out to the front building. Put these parts in the tumbler. I'm mildly disappointed about those handles and how they're not going to be perfect, but I've got a little solution up my sleeve here. Still meet my goal. So we've actually got 2 tumblers now. We haven't quite set up the second one yet. Almost there though. But so I showed Sky the dimples, and he goes, I could buff that out and make it look good. So we'll see. I believe him. So Eric got some new toys in here. Oops, sorry, Falcor, I stepped on you. Quattro-air.com air filters. They're made in Quebec. Nice Canadian-made company. They look amazing, right? Like they're
Yeah, they look really cool.
Qualité.
Really solid.
So we got 2 of them. One's in the other section right there. Yeah, so you've just got your tube up to here for now, like quick and dirty. Eric was saying when he's sharp, well, you tell me. Just speak up.
When I'm sharpening, like I have the belts going that way, so I figure having it here would try to catch as much dust as possible, but even with this here, I'm finding that the dust seems to be going all the way around the belt and then coming and just spraying me with dust on my stomach, like from under here. So I'm not sure where the best place to put the pickup is.
Experimentation.
Yep. But yeah, they're pretty cool. They come with 2 ports. So, like you could cut this hose in half and then have one here as well for 2 different grinders. But
what is that?
One for like 5 minutes.
What is that?
And that's just an on-off switch.
Oh, that's so cool.
Yeah.
Oh, so it's a clicky. You don't have to stand on it.
Right, yeah, I didn't install it for like the first week because I thought I'd have to like keep my foot on it the whole time, and when I'm sharpening, I'm kind of moving around a little bit.
Yeah.
So I just tried it now, and I'm like, oh, it is just on. So it's much easier to walk by and hit it.
Beauty. I like it. That is fancy.
And it comes with a little grate to keep the two filters separate.
Oh, so the bag actually captures the dust.
Yeah, this captures the big dust, and then the HEPA filter down here captures whatever the bag doesn't.
Oh, that's pretty slick.
Yeah.
If airflow is reduced, check filter bags. I like that. I figure we end the year strong by giving you guys all kinds of good footage. I haven't talked about stuff in a while, so I guess I have lots to talk about. Like the magnetic pin finisher and the new ultrasonic cleaners, and I don't know, lots of stuff. And Pierre, another machinist that just hired about a month ago. Lots to talk about. But today, we make some knives. So I'm taking this blade off. This blade that has the bad bevel on it. There's an operation at the end that cuts the tab off, and it's already done that. So there's no chance of saving it like safely because now it's not supported very well. I'll show you here in a second. So we have our blade with the tab on it, except on this side, I've cut the tab mostly down so that it does break off pretty easily. And then this part they can snap it off with the tin snips or something, or like a needle nose pliers, I mean, and then grind it down or whatever Eric and Sky have to do to get that thing nice. But you can see your transition line. They have a guide now of like where to grind that down to, and it's pretty easy to blend that nicely. But here's a good example. You can see the end mill. It's shiny, but it's kind of wavy. Like there's all these vertical striations or whatever the word is, whereas the grinding is just much more consistent. And this side was ground really nice. So other than the fingerprints, that tumbles out super good. So we have a friends and family knife right here. There's nothing wrong with it, it's just ugly. So moving on to the blades, here is my Delrin support. Pretty sweet piece of engineering, if I do say so myself. 3 screws to hold it down. It fits into the pocket. I mean, I'm sure it jiggles a tiny little bit when it's loose, but I made the fit pretty good. And then there's a 4-degree taper machined into it. So that 4-degree taper theoretically supports the blade fully. Now, weird thing, as I'm feeling with my finger right here, I feel a burr on this front edge. There is an operation at the end where, let me show you an example. Bad example. I don't know. There's an operation at the end where an end mill comes down and chops down the cutting edge and removes like 30 thou or something of distance this way. So that might be either machining the Delrin, I'll have to check the fusion cam, and kicking up that burr, or something is kicking up that burr. I need to make sure that doesn't happen, because a burr on the Delrin is going to kick up the blade, and that could be a cause of our problem. I feel like last time I was in here, I felt that, a week or so ago, and I took my knife and I, shaved it down, but it's back. So something's wrong with that. And that could be a cause of my problem right now. Because like if, it makes sense, right? Because the bevel is bulging here, if it's being pushed upward, then it's gonna grind here, and then the probe comes in and it hits that surface and it says, oh, it's perfect. But it's not perfect. Because the way I make these is I rough end mill, probe, offset, finish end mill, leaving a little bit of like a specific amount of stock, and then I rough grind, probe, offset, and then I finish grind. And then theoretically that's an awesome system, but if the probe is rough grinding that surface and offsetting it based on where it thinks it is, but that's not in relation to the whole bevel, that's bad juju. So I just got to do better. But I'm getting there. I'm getting there. So maybe I just need a big fat chamfer on there. And I might also 3D surface the top of this to make sure that in position it's where it's supposed to be. Okay. Tell me all of your secrets.
So the whole inside past this front, like this whole belly part,
yep.
The surface finish is always worse than all of the rest of it.
Why?
Don't know why. Norseman's the same. Always.
Weird.
Tried my best to buff out those dimples without rounding the edge too much.
Yep.
It looks pretty good, and it should look fine after tumbling and match the other side.
Okay.
There's a pretty ugly burr where that pattern goes with the
sure.
cross. So I'm just gonna kiss the edge of that on the wheel.
Nice.
Or else there'll be like little bumps on the
Yeah, I did feel that.
At the clip.
Okay.
Surface finishes on the side were pretty nice. Not like perfect, but I barely had to touch. Like I mostly just touched the insides of the handles, and everything else made up perfect.
Cool.
Yeah, like you could see the spine on that. Looks like immaculate.
Yeah, now it looks good.
I barely touched it. Zip tie up. I don't know if you have a preferred zip tie spot.
Nope, it's up to you, man.
It does kind of change how it will tumble. So like for accents, I will, on the Norseman, I'll swap the hole so that it gets evenly tumbled halfway through.
Can you explain why we put zip ties on?
Yeah, so this big gray box full of ceramic and miscellaneous other things has a huge motor with a weight on the inside that spins around, and it makes all this move like a fluid. You put your parts in there and they get beat up until they're shiny and smooth and nicely, evenly finished. But the walls underneath all this corrugated section is flat and smooth.
Well, you see it here.
Yeah, and there's water involved. So anything flat, like the inside of this handle, will just stick right up against it and it won't move. So the zip tie is like a 3D floaty object that the rocks will grab and pull it back into the stream. And then the clip. The Norseman clips are way worse because they have a flat top. These will probably be fine even, but the zip tie with the screw in there just helps you pull it out way easier. So, are we good to go?
Let's go.
Okay.
These ones have insulated lids with like sound deadening insulation inside. Makes a huge difference. Good stuff. All right, 2 hours?
Yeah.
Sounds good, man. Thank you. Bye, Falcor. All right, back on the blades. You can see what we got going on here. Sort of a weird perspective, but that's our blade. And this is that edge chopping code that I was talking about. If I go one above, you can see how much material is being removed thanks to the in-process stock display. Not sure what it's thinking about for that little corner right there. But this shows me that the edge and the Delrin spacer are almost like the same level. And there is a chamfer on that Delrin spacer, but it's obviously getting chewed up a little bit. So I'm going to look at tool 65. Let's go take a peek. I want to see how dead that thing is getting because it's cutting down a knife edge. 65, why is 60? It must be in the spindle. Wait. I don't think it's in the spindle. No. Where's tool 65? 65. I'm not sure where it is. You know what? It's right here. It's this is the prep station. so that you get a quick tool change. It's like prepping. It's going to call tool 65 next and then use it. So yeah, I just got to put that away properly and then inspect it. So I checked out tool 65 on my HSK40E tool holders. This thing does 3 different jobs on the current making Rasks. One is whoa, almost dropped it. It chops off the tab. And I was just looking under the microscope, that's where it's worn the most, is the actual corners of the flutes. It's cutting 60 Rockwell stainless steel, so yes, it's going to wear. So it'd see the most wear on that, and then it also uses the sides of the flute to go down the cutting edge and chop off that little bit. That part of the end mill looks fine, and then later it uses, I figured I've got all this extra flute way up here that is not being utilized, so let me plunge the end mill almost all the way down and then take the pocket clip, and I'm profiling around the pocket clip for that operation. So I get triple duty out of the one tool, because why not? And I figure I'm going to replace it based on the corner quality, like the tab cutting off operation. And then if I replace it because of that, then I always have a newish tool for cutting the edge off and for profiling the clips, and triple duty, love it. So that's fine, that's not the problem. The problem is, I don't know, I think I just need to clearance that Delrin insert more, put a bigger chamfer on it, because if that burr's kicking up, that's causing problems. But it's like, the edge is so thin, I want to support the edge all the way up to the edge with backing, with Delrin on the background, because the grinding wheel's coming in doing work. So I don't want to like clearance the Delrin too much that now the edge is unsupported, you know, like that. That's a terrible analogy, but you know what I mean. These little pocket loops, UV and LED, I used to use these guys all the time until a friend gave me an amazing Leica microscope, and now I haven't used this thing in forever. But I need it because I need to stick my head inside the kern and look at that edge on the Delrin insert. But I could take out the insert and look at it under the microscope, but I kind of don't want to. I kind of want to leave it in place, because if there is any jiggle, any shift, I don't want a repeatability issue putting it back in. So just, that's why. But I want to take a look at it right now. So there is a burr. I'm just trying to think the best way to do it. I mean, I could cut it away with my knife, no big deal. I could machine something, put a chamfer on it. I got options. The other thing I can't decide what the problem is. If the problem is the burr, I don't know, and it's kicking up the edge, then it's not machining properly, then killing the burr would solve the problem. But I'm also wondering if the thickness of that insert, it's hard to measure because it's a tapered insert, if that's a problem. So one thing I really want to do is I want to paint it with a Sharpie, and then I want to come in with a small ball mill, and I want to 3D machine every inch of that surface. And if it cuts away the Sharpie, then that means it was too thick. If it doesn't, then that means it was too thin. I have a feeling, because of the way that I made it, I'm thinking it's too thick. Now that I look back at how I made it a few months ago, I was like, that's not the most accurate way to do it. It should be machined in place, 3D machined, giving a proper contoured surface. So I do want to try that too. Maybe I'll do that and have it machine a bigger chamfer at the same time, and then 2 birds with 1 stone. Okay, let me think about that for a minute. All right, so I've got my 3D surfacing tool path that's going to zip, 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 zip. I put patches in the design workspace over all the holes so that the tool path isn't dipping into a hole. It's just assuming that it's a flat surface. It leaves a much better finish, much better tool path. It's going to take 8.5 minutes, which is a long time, but I don't really care. And one thing I want to be clear on is, because I'm trying to put my perfect dimensions hat on, and I want this surface to be dimensionally perfect to where I think it is. The funny thing with an end mill, I don't have one within reach, but when the end mill manufacturer grinds the end mill, it's always a little bit undersized from the nominal, from what they say it is. Because if you start with a 1/4 inch bar and you grind flutes on it and you want to actually cut an edge on it, you have to make it a little bit smaller than 1/4 inch. And that's fine, I've learned to accept that. But on the Kern, there's a laser beam that the tool goes in and it measures the actual diameter. So tool 33 has a diameter of 0.01555 inches. So just for clarity's sake, 0.01555 times 2, 0.0311, not 0.3125. I mean, it's a 1/10 and a half undersized, but I'm gonna put that into Fusion. That is the new tool diameter for tool 33. And then, yeah, the 1/10 and a half is not gonna matter, but I'm gonna do it anyway. And then I'm gonna Sharpie the Delrin, and then I'm gonna run that. All right, so here we have, I am surfacing the Delrin insert. Notice the pallet is tilted 45 degrees because I can. Again, I get to cut on the sides of the ball mill. Another cool update to Fusion in the past few months is this little tab right down there lets you hide your yellow linking moves, lets you hide your links. So if you really just want to see the cutting tool path, it lets you. And you can see my cutting tool path wraps around the part and turns out pretty sweet. So that means it's going to 3D the chamfer. I have a 5 thou step over, which according to quick math, here's how I calculate my step over cusp height. Cusp height is the height of the ripples in a wave. So if you've got a 1/32 ball mill and you've moved it 5 thou over, point to there's 5 thou. There to there measures 2/10. Yep, 2/10. So it's nothing. Like, it looks like a lot, but it's not. It's a tiny little tool. So yeah, let's run it. So before I Sharpie this thing and then machine it down, I cleaned it with Windex and I noticed something. See if I can get the camera. I don't know if I can see this. It's hard to get the angle just right. You can kind of see it from there. You're gonna have to bear with me here. I will use my precision pointing device. So these sections right here, that and south, so all of this is shinier than this. Now, I remember when I first made this thing, there we go, a little bit more focus. This is the original milled finish of the thing. This is surface that has been squished by clamping every blade and machining them. So clearly it's rubbing here, and that is really fascinating. You can just tell by the surface finish. So that kind of doubles my theory of maybe the burr is causing a problem, and maybe this whole area is just too thick because I really should be machining it in place, which is what I'm just about to do right now. So I'm going to Sharpie it and we'll be able to see how much material is getting removed, although when it's machining it'll be way back. How are we going to do this? I think we'll do it, I think it'll be 45 degrees like that. So, we'll have to I'm not going to be able to film it, but I'll be able to see like that. Okay, she's going. It's kind of weird to see it. Yeah, everything's looking good. Woo, it's fast. I totally forgot to Sharpie mark it, but I can absolutely see that it's cutting. Now I'm going to try something. I've done this once or twice, and I think it works. Okay, on the next retract, which means when it comes up right there, I turn the feed rate knob down to 0, I'm going to hit the stop button, and I'm going to hit spindle off. And then I'm going to open the door. I think this still works, and then I can pick it up and continue from there. Okay, it's very dusty in there. Let's scroll out. Okay. All right, I got some Sharpie on there. So now if I close the door and go spindle back on again, okay, and then go cycle start, and then turn up the feed rate, it should continue. Oh, that's so cool. Okay. Nice. It's not something I do very often on any of the machines, but it's cool to be able to do that. Let it go. Machine just finished. Rotates. Oh, interesting, interesting. Okay. Interesting. So, okay, hold on. The black that we see here was already machined when I added the Sharpie, so of course it never got machined away. Over here, it should have been, but clearly it was not a problem. But here, I Sharpied this, and I Sharpied this, and I Sharpied this, and it got cut away. And you can see how much fluff I machined away. So it's not a lot, but it's something. Well, that's pretty cool. Yeah, man, machining in place is the right solution. Well, now I have a code that does that. Brent's just like, we've been here for a year and I've been dying to know what this place sounds like in guitar.
It sounds pretty good.
Yeah.
I like it.
Code is posted and transferred to grind the first side blade bevel with my new tweaks. I've got a couple radial stock to leaves that I've moved for all the 4 different operations. I'm going to, this here is my grinding wheel, my Tool 200. I'm going to dress that because it's done a bunch of blades, and let me show you something kind of cool. In Heidenhain, it naturally tracks tool life, like in minutes. So you go to the tool table and you scroll down because it's an awesome touchscreen. Tool 200 is, so I put a limit of 400 minutes on it, and so far it's done 252 minutes. So it's, I mean, I can still get some blade out of it, but I'm going to dress it anyway and reset that, just because I've got new theories, new setups, new whatever. I want a brand new grinding wheel edge to give me the best result. So let's do that. Okay, calls up the probe first, and then it's going to change palette. First thing it's got to do is open the door. This Iroha robot arm is amazing. So it's going to grab that pallet. It's going to put it away into the rack. It's going to turn around to this other side. It's putting away the big gripper jaws, and it's grabbing the small gripper jaws. Then it's going to come up here and grab my pallet number 50, which is the truing pin. And then back around here, there it is. It's putting it in. Then that thing goes away, the door closes. It rotates to C home. There it goes. Probe comes in. Probe measures the top. I gave it a lot of silly, slow clearance. Boop. And then it goes in, and I want to make sure that that pin's going to wear down over time. I want to make sure I don't grind down to nothing. So I'm comparing. I think that first stop was just comparing how long it's sticking out, and now it's measuring the actual surface of that thing. Now it's calling up my grinding wheel. Coolant is going to blast, and this thing's going to go at a, oh no. First it's measuring starting diameter with the Bloom laser. So if we get it just right, once it goes to the other side, there you go, you can see the laser beam on the side of the wheel. So it's measuring starting diameter, and then it's going to grind off. It's going to clean up the wheel. The wheel's going up and down very slowly, and then over a hair, like not even a hair, going over a tiny bit. Takes a couple minutes, and then it will go back to the laser, probe the diameter of the tool, and then now use that as the future reference for grinding blades. It works so good. The one thing I haven't figured out yet in the tool table is when it just measured the tool diameter again, it didn't reset the counter. So I'm not, like, I can manually reset this, yes, and I will right now. So I go edit on, I type in 0, and then end, and then now I'm, whoa, what happened? 0 enter seemed to work. That was weird. I don't know why it took a couple tries. I'm doing something wrong. Yeah, I kept going, I don't know. It works though, it'll work now. Here it goes, touching the diameter again. And then we're done. Actually, we'll watch it right now. This is before grinding, and then in a second it'll update to be after grinding. There it goes. That is your radius of the tool, so times it by 2 to give you the diameter. Dun dun dun! Oh, look at that. Looks minty. So you can see, can you see? This guy's got a cup into it to form, you know, the wheel. It's this is wears out. But yeah, so I've always got it rotated, so it always orients to the same like C position when it's tilted down. Grind, grind, grind. So that cup is just gonna go down, 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 and that's why I have the measurement thing. So once this distance becomes 0.1 inch or whatever I programmed, then it alarms out. It'll be like, hey, replace your tool. Don't forget, you're gonna crash. Okay, so I need to manually call back the pallet because I don't have that programmed yet. So let's manually call that back in. And then since right now I'm only grinding the one side blade, so to do that, I've opened my blade grinding subroutine program, like master program. So it's like rough grind, rough mill, probe, finish mill, probe, rough grind, probe, finish grind, probe. You can see, yeah, probe, first side, finish grind. But I don't want to do the second side, so I'm going to go right here in the middle, and I'm going to type an M0, and I'm going to go end, and that's going to pause before continuing to the second side, so I can stop it after that. Done. And then we shall close the door, push the button. We shall go to the MDI screen. We shall type in workpiece number, pretty sure it's 9, but let's check again. Yep, number 9. And then we'll hit start. And my battery is just about to die. Again. Because I've been filming so much today. So, you've seen this happen. It's awesome. The palette change takes less time than the battery change on the camera. All right, good to go. Okay, grinding blades. First step, bring in the 3/8 Zidaro end mill. Palette rotates down. Cool it on. The palette is not square, it's rotated 4 degrees, 221 instead of 225. It's rotated 4 degrees forward because that's my bevel angle. So now the end mill being straight up and down can kiss that blade at a tilted angle, and that makes the bevel. And then I'm playing with the feed rate knob here, you know, stopped right now. There we go. So the cuts get progressively heavier and heavier as more of the bevel is presented to the cutting tool. Is currently taking 10% spindle load. Machining 60 Rockwell stainless. Yeah, like I said, every cut's getting a little bit heavier, so that makes sense. Because the contact patch, the first cut is like this, and then the second cut's like this, and the third cut's like this, and the fourth cut's, you know, a full width, or whatever the numbers actually are. So it makes sense that every pass is getting subsequently more spindle load. But seeing as how the scroll bar is almost at the end, we're on the last or second last pass. Spring pass, you can tell it's super low. Cool. That should be the last one. Yep. I've got the machine programmed always to go into the back corner before rotating the pallet or doing anything silly. Now the probe is going to come in and confirm what we just did. And if it's wrong, it's going to offset it. That's it, single touch. All right, I'll let that play. Hard conversation time. I guess I just made a mistake. Not a big one, but the machine shut off. And yeah. I'm not exactly sure why. I think I know what happened, but I'm not sure why it happened. Yeah, the machine overloaded. It was too heavy of a cut. There's an error about standstill monitoring error in C, and then emergency stop, and then excessive servo lag in C, and then saving service files. I guess that means the C axis was trying to rotate, which is the twisting of the pallet. But once I get the machine back on, I can look at some numbers and data. I think what happened is because the end mill comes in, it rough mills the surface, the probe comes in, touches it, and then it updates the tool offset for that tool by however far it was off. So if the bevel was off by 1 thou, it'll add 1 thou of wear compensation to the tool diameter radius. Except it looks like it added 70 thou of tool radius. 70, not the 1 or 2 it's supposed to. Meaning the finish pass for the end mill that comes in took a 70 thou bigger width of cut than the 2 thou it's supposed to. So I don't know what happened. I don't know why. I gotta be careful of this. Maybe obviously I have to put a limit on how much crap it can offset. I see it right there. Maximum limit, minimum limit. Yeah, I don't know. I doubt there's any problems. I doubt there's any damage. I think things are good, but it sounded heavy, but it sounded fine. I'm just kind of jittery. I'm like, oh, I don't like making mistakes. So I'll figure it out. The next question is, how do I turn this thing back on again? So like the light's off on the inside, it won't move. It says every button I push says key non-functional. You know, pushing start, e-stop, off, cycle start, even the main power button. Maybe if I hold it, I think I'll just have to shut it off and turn it back on again. Holding it doesn't work. I think I'm gonna have to hit the main disconnect on the back. All right, let me show you what happened. That was supposed to be a finish cut, but that is a big honker. That is a large cut for what I'm doing. It's supposed to be a little cleanup pass. Normally, these are the chips it's making during cutting, but these are the ones that were coming off during that cut. They're not super thick, like they are nice and thin, but they're wide and fat and blue because they got hot. These ones are slightly golden color, which is kind of perfect. Yeah, so you can see the blue chips peppered around because it didn't cut much, but started to cut into the fixture a little bit. It dug into the fixture a little bit there. No damage, like it's fine. I bet you even the tool is in fine condition. But something overloaded. Like I guess the C axis goes this way, so maybe it just couldn't hold the heavy cutting forces as they got heavier and heavier deeper into the blade. So it wasn't necessarily spindle horsepower problem. It was, I think, the C is like holding. And actually, there's probably a code where you can lock the C, like do a mechanical lock, and I obviously didn't do that. So it's not something I need to look into right now, but this kind of neat to know about. So if I look at, here's my big question, tool table, 200, not 200, 63 is the end mill, 200 is a grinding wheel. 63, not 63, 60, 64? Yeah, did 70 thou, what are you doing? That's the problem. So it just stepped over way too far. Okay, here's the thing. Since I still have viable bevel here, I can bring the probe back in and I can say, what the heck? And I can probe it again and see if it hit a chip or something, and I gotta set those limits on the code. This is the probing operation. And these measuring limit, positive and negative. I've got stupid like wide values right now. Clearly I can't do that anymore ever. So this is the theoretical position, 2.0572. I need to make this, 5 or 10 thou on either direction of that. Otherwise it'll alarm out. All right, that's what I'm doing right now. I have a theory. I think I know what I did wrong. Okay. And imagine if this is the probe tip. Now, when it used to come down, it would touch right at the top, because I figured that was a good indicator of the bevel position. But I changed it last night, I think, to be deeper, because if we're looking at the blade that didn't get machined properly, if we're touching up here, the tool, the touch probe thinks it's fine, thinks everything's golden because this machined surface is actually accurate. So I changed it to touch down here a little bit, but maybe I went too far, or maybe I went the wrong direction or something. I never tested it because I'm dumb. I didn't watch it while doing it, while being scared, while doing like you're supposed to do. I just kind of sent it, and it bit me, and I forgot about it. So I'm going to run it right now, dry run of the probing operation. It's not going to update based on the results. It's just going to like give me an answer, and then we'll see. I don't even know where, like how far down I made it. I changed it a certain amount, but I haven't seen where it's actually hitting. So I'm going to do that. Oh, I know what happened. The freaking body is too big. The tip of the tool, of the probe, I went too deep. You gotta see this. The side of the probe, like the shaft, is going to hit. Watch, okay. Focus. Let's see. Duh, you dummy. Well, we have our answer. So I love, I feel really dumb right now, but the thing with CNC machining is it should make sense. It's numbers and math and consistency and measurements and details and movement, and it should make sense. When it doesn't make sense, usually I try to blame myself, because the machine will only do what you tell it to do. It's not smart. It has logic, but you program the logic into it. And when you're stupid and you don't check things, that logic fails. Okay, that's a result. Results are good. I don't mind making mistakes. I learn from them, but I wish I don't make mistakes. You know what I mean? Okay. Well, that answers that. Okay. Like that's the weird thing with hand editing probing routines and master files that call subroutines, and you're adding little things here and there. And I'm not doing much of it, but I'm doing a little bit of it on the kern, and it bit me. So I gotta be more careful. I just gotta think, I gotta see, I gotta visualize, I gotta test carefully. Okay, but that problem is solved. So let's put another blade in there and try this again. Like fix it first. Okay, I think I'm getting it. Okay, so I put a maximum and a minimum limit. Now, since the numbers are in negative for this particular side of the tombstone, I have to flip them. Minimum is the lowest number below 0. Maximum is the closer one to 0, with my nominal being 205. So I have a range of 204 to 206, 10th out plus or minus, which is kind of a lot, but it's not going to cause a problem, like a big problem. I don't know, I can fine tune it later. And then I just probed it, and also I have, if you turn on this one, program stop tolerance to 1 instead of a 0, it'll pause the program. So 2.05 is the goal. It just measured at 2.11, and it gave me measure cycle length below minimum error, and it stopped there. So that's great. That's progress. So next I'm going to edit over. I need to change this to 1.67 is my new ideal starting height, and then this should work. This should work. This should pass, actually. Okay, it's going to come down. This will be the new probing height. Let's see if I got it right. Yep. Bang on. And no error. And 2.0537, it goes away, which is stupid. 2.0537, so we're 4 thou under. Since I have measure log, it writes it to text file, which is here. And if I go, I can't do that. End, page down. Yeah, no. I gotta page down all the way. That'll take forever. Yeah, this is what we just measured. 2.057 is the goal. 2.053 is our measurement. Our deviation is 3 thou. This is good. This is good. Okay, now I just have to apply that to all the probing routines, and then we're golden. Okay, the other thing I got to do, I'm going to take a little break from grinding bevels and making mistakes. Do some other stuff. Free my mind for a little bit. The other change I made that I haven't tested yet, like I changed the angle of the locking face on our blades, where the lock bar bends over and gets in the way of the blade so that the blade can't close. Getting those details to be perfect, there you go, is tricky. And we've been lucky on the Norseman because it just works. It's been perfect forever, like since we messed with it a long time ago. On this knife, we're having troubles. Things are different than I expected. We're doing lock bar inserts. This camera does not like to focus quickly. Hardened stainless steel lock bar insert, so that changes things. My particular knife here sticks. The lock bar clicks and sticks into place, and I don't like it, and it feels gross. And that's due, I think, to the geometry of the blade tang, and these new blades, not this one, this one, I have changed it, but I haven't test fit on the knife. So let's bring this over to Eric. Let's check on the handles that have been in the tumbler now for 3.5 hours, unless Eric took them out, which he probably did. Unless Eric's already gone home, I don't know yet. It's 8 o'clock at night. I hope he's gone home for his own sake, but let's go check on that. And then I do want to test fit this knife. I want to check the lock. Either it sticks like this one does, or it will fail a spine whack test, where we take it against a piece of wood and we go bam, 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 bam. We're trying to fold the knife. I tried one test a couple weeks ago on blade number 17, which is here somewhere, where I went too far and it fails. It'll fail the spine whack test, but there's no lock stick. So these new ones are right in the middle. The failure was 4 thou movement. At 0 it sticks, at 4 thou movement it slips. So I made these 1.5 thou movement, angular, whatever I did. So let's see if it works. It got dark. I see the lights are still on up there. So maybe he is still here. Last day of the month, he's really pushing to get as many knives out the door as he can. Finish them up. Respect. There's nobody here. Okay, so this blade that I'm testing happens to be, well, I'm digging into the production blades. The old ones were labeled prototype, whatever, 01, 02, 017. This is Rasks 330, which was supposed to be the first like sellable production knife, but this is the one we screwed up the bevels on. However, as I said, the lock is good, so we're gonna barrel lap the pivot using an expanding mandrel brass thing with diamond 5 micron. I forget what diamond micron we're using. Polishing paste in a drill. It'll just clean up the inside of that hole and it'll open it up to the exact right diameter we need. we test, we fit, make it good, and then we're gonna polish the lock face, just get the heat treat like color off, and then we'll test it. I have shined up the lock face. I have barrel lapped the pivot. See if you can see how shiny this thing is on the inside. It's shiny. Good. Now let's throw it together in Manaf. Doesn't take long. Okay, here we go. Flips good, feels good. Drops good, flips great, drops great. It's got no lube on it, so that always helps, the drop. Okay, is there any lock stick? Let's find out. Give it a good hard flick. No, that feels great. No lock stick whatsoever. That's good. That's great. That's great. Will it fail? Let's find out. This is something, you guys will like this. We've been doing this forever. You can see how much Eric uses his block of wood. This is not his, he's got a side here and here and here. And this is not our first block of wood either. Every single knife we make gets spine whacked. And if it fails, we fix it or throw it away or whatever. Goggle up. Okay, yeah, all we're trying to do is we're trying to fold the blade. We're trying to see how much it can take. Hey, buddy. It's good so far. I don't care. I think we're working. You wanna try? Eric's in the bathroom.
Feels good too.
Feels good, no stick?
No stick. No slip.
Oh, I think we're onto something.
Flip is nice. Lock is nice. Send it.
Yes.
We're good.
I think we have a product.
Approval.
Maybe we should make a business out of this.
Yeah, maybe. We can make another.
Good.
No, that's great. Bevel didn't work out that well?
That's not today's bevel, that's the other day's bevel. Today's bevel didn't work out so good either.
No.
You'll like it when you see that one. It's like super deep cut, like half the bevel's missing. Oops. Did those handles ever get out of the tumbler?
These aren't them?
No.
Oh, okay. Yeah, they're just dry.
In sync, okay. Oh. Sweet. Curious how Sky's blending worked out. I mean, it looks pretty good. Oh, I'm really dragging, guys. It is 10:17 p.m. We're grinding blades. Got it all figured out. Got the probing to do what it's supposed to do. The end mill's fine, the machine's fine, everything's good. And next round was almost bang on. The probing was within tenths of where it should have been. And that's good. That's really, really good. So this is the grinding wheel on there right now doing the rough grinding. And then it's gonna probe, offset a little bit, and then it's gonna do the finish grinding, and then one side is done. And then if I decide to stay super late tonight, I'll flip it over and grind the second side, see how the support works, see how the consistency works. It's coming together. I was texting my wife and she said, don't stay till next year. And I was like, yeah, I shouldn't do that, should I? But we'll see. I don't want to, but I would. Okay, I paused it after rough grinding. Probe came in, measured it. It is measuring 6/10 to 6/10 too big, which is amazing. That's fantastic. I think with time, that'll get a little bit tighter and tighter and tighter, like more repetitive. So it offset the grinding tool diameter on a fresh dress by 6/10 smaller, which is like amazing. So next, the finish grinding is going to come in. I'll set that up now. And then we'll see how accurate that is, and it should be awesome. All right, finish grinding finished. It is less than 1/10,000th of an inch off from where it's supposed to be. Oh man, that's awesome. Let's take a look. I'm in that like exhausted, giddy phase right now because it worked. And oh mama. Yeah, she bangs. That looks so good. So good. It's like hard to film, it looks so good. Okay. So that's fantastic. So I'm going to flip it. I'm going to stay here for another half hour, 40 minutes, whatever it takes. It's 10:50. New Year's Eve. Maybe I'll be able to get out of here before midnight. Not that I care. I don't do New Year's Eve. I'd just be at home watching movies right now. So I'm here watching Jay Pearson on YouTube. Okay, let's flip it and go. The time is 11:34 p.m. And this was me about 10 seconds ago. No! It still missed a couple spots on the bevel. I'm done. I'm out. Can't do this anymore. Better. But what the heck? And that, ladies and gentlemen, is the end for me tonight. I'm done. I'm literally throwing in the towel. That's okay. I did a lot today. I'm pretty happy with the results. Still confused why that's still a problem because everything is literally perfect. But I'll think about it. I got the next 4 days off. New Year's weekend. Gave all the guys next Monday off, so we're coming back on Tuesday, and I'm going to try to not think about work for the next 4 days. I did good over Christmas. I had 5 days off and it was fantastic. So anyway, yeah, I'm gonna go home, turn my brain off, and see you guys next year. All right, thanks for watching this epically long video. I'm sure you enjoyed it. Take care, bye.